ॐ ध्यायामोदवडावगुण्डनवदीं तेजोमयीं नैष्टिकीं स्निग्धापाङ्गविलोगिनीं भगवतीं मन्दस्मितश्रीमुखीं वात्सल्यामृतवर्षिणीं सुमधुरं सङ्कीर्तनालापिनीं श्यामाङ्गी मधुसिक्तसुक्तिम् अमृतानन्दात्मिका ईश्वरी।
Om Amradeshwari Namaha. Namah Shivaya. Hearty welcome to all the participants of AstroClub, and most hearty welcome to our Kiran Mohan sir, who has joined with us today. About him, we need a long introduction because he is such a great person, and he has a what you call as great mind to come to our screen and share his knowledge. So I am not wasting my time. So let us invite our Kiran Mohan sir to our AstroClub. Sir, welcome.
Good morning, madam, and good morning all the students or the participants of this program. Ma'am,
Yes.
should I speak in Malayalam or English or mix both?
English, ma'am. English, sir. English.
Okay, you want us to be in English. Fine. So
yes.
I'll go about in English then. Huh?
Yes. Yes.
I would prefer that if after each of the slides, if any of you have any doubts regarding any of those slides or anything to ask me, you can always raise your hands or interrupt me in between. So take this as a very informal thing. I'm a very young engineer at ISRO. I'm not that old. So consider yourself as one among yourself. Okay. I do take a lot of classes like this. As ma'am was pointing out, I'm a rocket scientist. I'm a mechanical engineer with a master's in propulsion and thermal engineering, and I work on rockets basically. And astronomy has been a hobby since my childhood days. Like when I was a kid, from maybe my 6th standard or 7th standard, I used to observe the sky, use a small telescope, take photographs, and then it has been a passion. Or sort of a hobby, a passion and a hobby to me. So today I'll be talking on comets because we had a green comet that has passed by, and a lot of news was there and news coverage was there, and probably a few of you would have seen these things also. I mean, one of these things also you would have seen. So okay, so I hope my slides are visible. Is it? Can anybody respond, please?
Yes, it's visible.
Yeah. Okay. So I'll just. Okay. Now I've named the slide as the comets, the wanderers of the solar system. Basically, because the comets, as you all know, they come from a very distant regions of our solar system. Basically, they come from some places called as Oort cloud, or they are called as a trans-Neptunian objects. Basically, the objects which are beyond Neptune. Now, as you all know, solar system consists of the sun and a lot of planets going around, 8 of them. And then there are many other small rocky bodies. There are asteroids, there are geeks, there are trojans. Likewise, there are many things which is going around the sun. Now, any object which is beyond the orbit of the planets, that is beyond Neptune. You know that we have Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. These are the 8 planets we are having. And beyond that, that is beyond the orbit of Neptune, whatever objects are there, they are called as trans-Neptunian objects. Now, these trans-Neptunian objects are again classified into 2 sections. One is the one portion is called as a Kuiper belt, and then we have the Oort cloud. Now these are the 2 segments that comes beyond the Neptunian orbit, and Kuiper belt as well as Oort cloud, the rocky bodies there. Those bodies, when they come near to the sun, those things are called as, basically they are called as comets. And as you all know, comets has a tail. Now you can see this background of my photo. You have got a scenery where there is a big comet, and the comet has got tail. And you can see that the beautiful tail, which is almost just going around across the sky. So comets are basically objects which are having, they are called as hairy stars, and the term itself is derived from Greek, meaning hairy star. So it looks like a star with some a big long hair. Okay, so these are called as hairy stars, and the recorded earliest observations comes from around 1000 BC from China and from Iraq. Now we have not yet identified which comet probably that this particular recording is of, and probably it would have come and gone, and we do not know as of now. We do not know which comet is this particular observation about. Now, so comets, as you know, as the slide suggests, it has been recorded from the prehistoric time. That is, early human civilizations itself has recorded it. And the sky, basically, the objects in the sky, basically the sun, the moon, the stars, and all the wonders in the sky, they were used as calendars. They were used for predicting time. They were used for making calendars. And that calendar systems derived from the sky was basically the essence of any civilization. That led to the civilization to cultivate things that helped them predict weather. They helped them predict the rain, the sun, everything. So the success of a civilization basically depended upon the sky and the objects in the sky and their apparent motions, and that is why from which the calendar itself is drawn. Now, for those people who looks up at the sky and as a calendar, some objects which is coming randomly, moving across the sky in a matter of some 2 or 3 days to a few months, and then disappearing all of a sudden, those objects those objects used to scare them, because it is something which they were not able to predict, which they were not able to conceive what these objects were. And usually, because of this, the comets were usually seen as as something like a doomsday object, and comets were always considered to be linked to some scary things, some war, some famine, some drought, or something like that, because those were some things which you couldn't predict. Nobody knew when it was coming, how it was coming. And we'll just go through, my slides are structured in such a way that we'll go through some history. We'll try to know how the theory of comets evolved, or how we started understanding what a comet is. And then we'll go to a few photos which we have taken of the comets. And then I'll also talk about some of the interesting facts about comets, and a few comets which has been marked in history as something huge. So coming to the next slide. Okay.
Sorry to interrupt, sir.
Yes,
Can you on your camera, sir? Can you on your camera?
Since I am presenting, ma'am, even if I am.
Oh, okay. Yes, at the end you can. Yes.
Yeah. Okay, I'll do that.
Okay.
Okay. So as I was mentioning, it was always considered to be omens of doom, because they were very spectacular, basically, very irregular and unpredictable, and so you are not able to predict it. So you are scared of anything which you cannot predict, and that is why comets are usually thought to be the omens of doom. Now, some of them did consider them as something good also, but that's very few. Now, for example, you can see all of these events were in a way or the other related to the appearance or the disappearance of a comet. And but it does not mean that whenever something bad happened, a comet was there, or whenever a comet came, something bad happened. That is not the case. But it so happened that when these particular events happened in history, there was a comet around. And I can tell you with clarity that from 2019 onwards, when 2019 to 2022, there are at least 9 comets which we have photographed. Maybe it was not that public a news, but I'll show you all the 9 comets also in the photographs which we had photographed from Trivandrum. So the appearance of a comet is not that scarce an event, but the appearance of a naked eye comet is going to be that scarce presently, because of the light pollution, the atmospheric pollution and all. And comets are very diffuse objects. So though the comets as such are not that rare, the naked eye comets in the present day are very rare. That's why we don't find much of comets. You may not have seen a lot of comets, but in actual, per year, 3 or 4 comets are there which is visiting us and which can be photographed or which can be seen through a small telescope or a binocular. We'll come to that a bit later. Okay, now these doomsday stories have also been inspired not just in the prehistoric times or the historic times, but recently also, even with the war of Russia or Ukraine has been attributed to 2 comets. One is the comet that we are presently seeing, and there is another comet which appeared some 3 months back. And these two comets are supposed to have brought the war on Ukraine by Russia. Though we know that the war itself started long back, but in history it will be recorded. These comets will be recorded and in this particular name. So the poor comets has nothing to do with it, but we do accord such events to comets, even now, even today. Please don't believe that it is something which was old day story. No, it is still now it happens. Now, the Chinese astronomers were one of the first to record comets, and these are the recordings which we see of. And you can see that they have recorded the comet as with a head and a tail, and you can see that there are multiple tails. There is no one tail; it is multiple tails they have recorded. And for the matter of fact, as a matter of fact, every comet has at least 2 tails. So minimum 2 tails will be there for any comet, and so these observations were very accurate. In fact, and the recordings they have done, there is no comet in any of these recordings where a comet is there with one single tail, which means that they were keen in observing and they were keen in recording also. Now, so these are very accurate depictions of comet, and the time, the date of appearance, the date of disappearance, everything is being told. After those early days in China and Iraq and maybe some portions of India, then some people who started looking at comets in a scientific fashion, or maybe in a very in a very interesting way, was basically Tycho Brahe. Tycho Brahe is a person who is very well known for not for himself but for his disciple Kepler, who derived the equations of planetary motions. That we'll come to him later. But it was Tycho Brahe who actually observed comets in a meticulous way. He recorded his findings, and the Aristotelian thought that comets were celestial objects below the moon was changed by Tycho Brahe. Up to that point of Tycho Brahe, people were thinking that Aristotle had given a notion that comets are probably things which are existing between moon and earth. So it is something below moon is what was thought of by Aristotle, and it was not basic. So it was basically a philosophical thought rather than a scientific thought, and this was challenged by Tycho Brahe through his observations. Okay, he used a method called as parallax method for observation, and in 1577 he gave the comet of 1577 he used for measuring the distance of the comet with respect to the moon, and he found that the comet has to be very multifold distant, or multiple times the distance from Earth to the moon. So comet has to be traveling through a path which is very far off when compared to the distance between the moon and the Earth. And it was Tycho Brahe who unambiguously proved that comets are something beyond the orbit of moon, or something which is very far off from Earth. Now, again, using all these data, Kepler, his disciple Kepler, who's renowned for his theories on planetary motions, all the 3 theories of planetary motion which we still use and which we still hold on to, all rockets, everything works with those equations, and those equations were derived by Kepler. So Kepler was also keen in cometry. So he thought, in fact he thought that comets are some spherical objects which are transparent and which refracts sun's rays. So he believed that they were objects that is very transparent and which has the capability to take in light from the sun and glow by itself by refracting the light. And according to him, when the sun's rays passes through the head, they expel a stream of something called as effluvium, or some particles or some flow is being ejected into the space around. And he also prophesied that probably this particular stream of gas or stream of effluvium, as he called it, that effluvium is coming out, and that effluvium is basically moving in the direction opposite to that of the motion of the comet. So the comet is moving in one path, and the light comes and hits the comet. The comet then something happens to the comet, and that it starts ejecting things, and those things moves in a stream behind this head of the comet. That is what he thought of, or from his observations, or from Tycho Brahe's observations, this is what he theorized basically. And this stream, according to him, was obviously denser than pure ether or the matter surrounding it, and that is why it reflects the sun's radiations, and so that the effluvium or the tail behind it is also bright. So that is what he thought of, and to the present day understanding, it is something which is very close by. It is one of the closest explanations of why comet has a tail or the comet has some the tail is glowing. So this is what he could understand. Believe me, it is in the late 1500s and the early 1600s, and so many telescopes, nothing was there for him to decipher all these things. It was his pure the scientific temper which helped him understand whatever, or helped him decipher the little bit of information which we had from Tycho Brahe's observations and his own observations. Now, the path of the comet basically was derived by Newton. So Newton was the first person to, in fact, include comets as a member of the solar system. So by the Newton's time, Copernican theories had come, and then people had started believing that sun is at the center of our solar system, and some things have started moving around the sun. That is basically the planets are moving around the sun. These notions were theorized and accepted by the society by the time of Newton. And Newton, in fact, included, he was the first one to say that comets are nothing but some objects in the solar system and moving around like planets, but in a very weird, very weird manner. Okay, and so Newton tried to he invented the modern era scientific term called as cometology. Cometology is the branch of science which deals or studies specifically about comets, and he was the first person to do this, or he was the father of cometology. Now he started trying to, he actually tried to model the comet as a part of the solar system, and he tried to take a comet and he tried to trace its path around the sun, and he found that they have very elongated orbits. All our planets, if you see, all the planets has got almost regular circular orbits. The orbits are very nearly circular. The eccentricity of the orbit is very small. Of course, they are having an elliptical orbit. It is not exactly a circle, but they are still very near to a circle orbit. The orbits of any planet, if you take, they are very near to a circle rather than near to an ellipse. But they are elliptic, slightly elliptic. But in case of comets, they are extremely elliptical orbits, such that it comes as near to the sun as possible. That is, it comes very near, so near to the sun that there are comets. I'll be showing you one of the photos of a comet which actually moved through the atmosphere of the sun. It entered through the atmosphere of the sun and then came out. So it goes to as close as, the comets goes as close as touching the sun, and then it goes so far away. It goes all the way across the solar system. It crosses Neptune's orbit, reaches to the very much outskirts of the solar system and comes back. So those are the places where light itself will take almost 1 year to reach. That is, the sunlight will take almost 1 year to reach those distant places of the solar system. And the sun, from that location, it looked like any other star in the sky. So it is so distant. So from those distance, it comes so close to the sun and then goes back. So this particular notion or this particular finding or observation was made by or mathematically proved. Actually, the observations were mathematically proved by Newton. Now, so according to Newton, this is the path of the comet which he drew. So the comet is coming like this and it is going like this. And in this figure, you will be very curious to note that the comet's tail, if you see the comet's tail, actually the comet is coming like this from the outer solar system. Then it comes to the very near to the sun. That point here is the sun, and B is the nearest point to the sun, and then it goes back and it goes like this. Now you can see that the comet's tail, if you see, the comet has a tail here, and the comet, it is moving from R to Q, Q to P, P to O, P to N, O to N, and it goes on. So it is moving from right to the left. So when it is moving from the right to the left, you can see that the comet's tail is actually behind the head. So comet is having head first and the tail at the behind the head, and the tail is following the head. But when it moves across this point and then it moves away, it starts moving away from the sun. So when it is starting from the left to the right, when it is moving, you can see that the tail is in front. The tail is moving front and the head is moving behind. So this particular image, which was drawn by the Newton, it actually does not only depicts that the orbit of the comet, but it also depicts the way in which the comet moves. That we will talk in a later slide why it is happening so. So what you have to understand from here is, one is that the Newton not only had mathematical skills, he had the observational skills too. So, and he believed the observations of Tycho Brahe and Kepler, who had actually prophesied this, who actually said that there is something happening when the tail and the head, when you see the apparent position of the tail and the head, when it is coming towards the sun and it is moving away from the sun, are different. So that is also depicted here. So just keep in your mind that when a comet comes towards the sun, the head is in the front and the tail is at the back. Whereas when the comet moves away from the sun, the tail is in the front and the head is at the back. So it is something which is not similar to what we see around in the in our day-to-day life. Now, Edmund Halley was is the most linked person, or one of the persons who are most linked with cometry, because Edmund Halley was the first one to actually say that comets are objects which returns back. According to the Newtonian theories, you can see that the end of the other point where the orbit gets closed, the orbit does not seem to be closed here. According to Newton, it comes, he doesn't know from where it comes very near to the sun, and it moves totally away from the sun. So he never knew that, or he couldn't predict that the comet comes back. He just knew that it is orbiting, or he did not know how to link a comet to another comet which was observed earlier. But it was Edmund Halley in 1705 who took the Newton's notion. He took the Newton's notion, he extended it, and then he started compiling the data that was available for him since prehistoric ages. So all the data he took together, and he found that the comet that came in 1531, in 1607 and 1682, these three observations, the orbital parameters of this comet and the size of the comet, the shape of the comet, all these things are very similar. So in 1531 there was a comet, in 1607 there was a comet, and in 1682 there was a comet with similar trajectories, with similar parameters, with similar sizes, the similar shape, similar tail configuration, everything. So he observed that he thought that probably these are the same comets, and then he extended Newtonian ideas. The Newtonian ideas of this this trajectory was taken. He put it into this framework, and he found out that he theorized basically that all these three comets are exactly the same. So it is the same comet which has come in 1531, which returned back in 1607, and again returned back in 1682. And he prophesied that probably, he theorized that he predicted that it should return after 1682. It should return in 1758. Though he waited for its return, but Halley was not fortunate enough to see this, but because Halley had passed away in 1742. And the scientific theories which he put forth held good, and instead of 1742, the comet actually reappeared. And though he predicted in 1758 December, the comet reappeared in 1759 February. Only a matter of 2 or 3 months gap was there. So according to his prediction, it came back in 1759, and henceforth that particular comet is named as Halley's comet. It has a periodicity, or it has an orbital period of almost 72 years, and every 72 years it returns back. Now, the last appearance of the Halley's comet was in 1986, 2 years before I was born. So in 1986, it had come, and people from all over India, especially from Kerala, because it passed through the southern hemisphere, so it was very much visible from Kerala. People had to come to Kerala and Tamil Nadu to see this particular comet in that year. So in 1986 it came, and 72 years later it is going to come. So maybe we'll be there to see, hopefully. Okay, so that is about Halley, but Halley's contribution is basically to the understanding of the trajectory of the comet, and his contribution, his predictions, or his scientific theories. It proved that any comet would return. It is actually the same comets which return once and again and again and again. They return to the sun and then goes back. Now, depending upon, about the tail, again people started thinking about it. Then you have Olbers and Hebesels. They were all there. You can see that they are all not specifically people who are only looking after comets. They are all known for some other scientific explanations, scientific proofs or theories which they had theorized. For example, Bessel is known for the Bessel function. He's a mathematician basically, and all these things were their hobbies basically. The astronomy was sort of a hobby for them, but they were so interested in this comets that they started explaining what the tail of the comet is and all those things. Now, with the works of all these people around, we now have an understanding that comet is an icy body. It has a very big head, which is composed of ice, basically water ice, carbon dioxide ice, and ice of methane and ethane. And then there are dust particles. All these things form a big globe, or a big potato-shaped thing, and that is the head of the comet. And then when these things comes very near to the sun, that is when once it crosses the orbit of Mars, That is the point, or it is called as a Goldilocks zone, where the temperature is so high that water and carbon dioxide will start to vaporize. So when water and carbon dioxide vaporizes, those are ejected out. They come out as streams of gas from the comet's head, and they are left out of the comet, and that forms the tail. Along with that, some dust particles will be there, crystalline structures will be there, some proteins are there. All these things together forms the tail of the comet, and the color of the tail of the comet depends upon the composition of the tail. So looking at the comet, looking at its tail's color, you can say what is the composition of the comet. Now, later on from 1986 onwards, there has been missions, satellite missions are there, spacecraft missions are there, which has gone, landed on a comet, which has gone through the dust trail of the comet, and all those things. We'll come to that in a short time. So now we have a very good understanding of what comets are, and there are certain interesting facts about comets which we will be learning. Now, one of the first, I mean, we'll now go into some of the things like the new era of cometry. All the things which we talked about right now, they were all old era cometry or cometology basically, and people were trying to see from observations. Now in the modern era, since 1980s, we have started to understand, or we have started to see whether I can go touch a comet, whether I can go grab a comet, whether I can take some materials and come back. All those things has happened. Okay, the first ever mission, the scientific mission or the spacecraft mission to explore a comet was called as ICE, or International Cometary Explorer. It was done in collaboration with NASA as well as ISRO combined together. NASA in collaboration with ISRO, and it was a combined program. And in 1985, it passed almost 7,800 kilometers through it passed within that particular distance of comet, called as, the comet's name is there. It passed through the comet's core at a particular distance from the comet's core, and it collected data. It was not that nearby. Of course, it was designed to be going very nearby, but the comet's trajectory is very erratic, and this ICE did not have much of a propulsion system to go any much nearer. When it was launched, or the mission was planned to be very near. It was supposed to be a flyby mission, which was very close. It was supposed to go very close, but it did not happen. Instead, it went past something around 7,800 kilometers away from that particular comet's head. But of course, it returned excellent data on the comet's tail. And for the first time, we got the confirmation that the theory is what I told. That is, comets are dirty bolts. They are not transparent objects. Instead, they are dirty bolts, which composes of a head which is formed from carbon dioxide ice and water ice with a lot of dust. And then what the tail is basically this gaseous carbon dioxide, gaseous water, and all those things. That theory was proved by ICE in 1985, and this was actually a precautionary spacecraft or an experimental spacecraft to see if in 1986 some other spacecrafts can be launched, and our Halley's comet, which is a well-established comet with a well-established path, whether that can be explored in reality. So this was an experimental mission, a precursor mission to the Halley's comet missions. Now, Giotto in 1986, Giotto is one of the most, one of the first as well as most celebrated missions in the history of cometology. Basically, it took the photos of the Halley's comet nucleus. This is the Halley's comet nucleus, the nucleus of the Halley's, because Halley's comet is one of the most celebrated comets in the human history. A lot of people has been around or behind this Halley's comet for a lot of years, but nobody has seen exactly how or what the Halley's comet's nucleus or the head would look like. So Giotto in 1986 was the mission, which went almost 600 kilometers as close to this head, and it took actual photos. It took almost 2,000 images of the Halley's comets, and then it returned back those photos. And actually, there were 4 missions which were sent: Vega 1, Vega 2, Susi, and of course our Giotto. Out of this, Giotto was one of the most successful missions. So this is the thing, and you can see that this is the comet with its with lots of streams of gas and ice coming out. And this forms a tail basically. And all these photos are taken before a profound tail is formed, because once the tail is formed, it will not be easy to go near to this object, because a lot of ice chunks, pieces of ice, bits and dirt bags, everything will be thrown out. And missions can get endangered because those objects can hit the spacecraft and damage it. So before the tail gets formed predominantly, that is, we'll try to encounter these objects near to the orbit of Mars. We will never allow it to cross the Earth's orbit. Once the Earth's orbit is crossed, then the amount of gasification, the amount of material that it throws out will be huge. So it will not be that easy to go and capture the photo. So what we do is we will take the spacecraft, we will take it near to the, we'll launch it in a way that the trajectory of the spacecraft and the trajectory of the comets will be meeting somewhere near to the trajectory of Mars, or in between Mars and Earth, not after that. Okay, now there was another mission in 2004 which is called as the Stardust mission. This is one very famous mission. This is for the first time ever that we encountered, we actually went into the path of a comet. We went behind the comet. We went through the tail. We actually went through the tail, collected some dust from the comet and returned back. Okay, so there was this mission. It's called as a Stardust mission. That spacecraft went near to a comet called as Wild 2. Wild 2 is a comet. It went through the comet. There was the tail of the comet. It went through the tail of the comet. It flew through the tail of the comet. It collected some of these dust particles and then came back. Now it is not that easy to collect the particles, or it is not you don't open a bottle of something and then collect this data. No, because these objects or whatever, even the gas, the dust that comes out of the comet are at a very high velocity. So you have to slow it down. You have to preserve it and then bring it back. So for this particular thing, what they had done, I will show you the actual photos also. There is something called as an aerogel. It's basically there is a mesh or a net. There is a structure with a net, and this net is actually filled with an aerogel. There is a jelly substance inside this, which is called as an aerogel. And this aerogel, what it does is it's a very thixotropic gel. It is very thick and it is very dense. That is, density is very high. So what happens is when this particular spacecraft is passing through the comet's tail, the particles that comes and hits this gel, because it is very dense and it is very it actually absorbs that energy. Whatever energy or the velocity or the kinetic energy, the potential energy that particular particle has, those energies absorbed by this aerogel. It deforms and it is like swallowing. The aerogel actually swallows those particles. So those particles comes, hits this aerogel, loses its velocity, it slows down and gets engulfed inside this aerogel. That is what happens. And one of the biggest finding of the Stardust mission was that it discovered glycine. That whatever material that came out, or material which was returned to Earth by this mission, when it was studied, we found that it had glycine. Glycine is a building block of life, and from this particular mission, we understand that probably Earth is a planet which is very much internal to the solar system. It is very much interior to the solar system, and according to the theories of formation of the solar system, water, proteins, carbon dioxide, methane, and such smaller molecules or organic molecules should not be found in a place like Earth, because Earth is supposed to be composed of, because of the differentiation processes and all, Mercury, Venus, Earth, and Mars. These are the 4 planets. They are called as terrestrial planets. And according to the theories of formation of the solar system, these planets, or the inner solar system planets, or the terrestrial planets, are supposed to be composed majorly of metals, basically very high density metals, high density particles, metals, and non-metals. Some of the non-metals only. Non-metallic particles are supposed to be very low. Metallic particles are supposed to be very high. And there is no way Earth or Mars or Venus or Mercury can actually have water. According to the theories of formation of solar system, neither water nor simple organic molecules can exist on Earth. So probably now we are theorizing that, and with this discovery, we know that comets, basically from these satellite studies, we know that the comets are basically composed of 90 to 95% water ice or carbon dioxide ice. And we would have had a lot of comets which has come and hit Earth in the prehistoric time. And so now we believe that probably it was comets which brought water to Earth. So the water we drink, the water we wash us with, the water we use for cooking, that water probably has come from comets which has come and bombarded Earth long years ago. And with Stardust mission, we know that comets also has fundamental building blocks of life, and probably we are not sure of this, but probably we still believe that probably the building blocks of life was brought to Earth by these comets. It doesn't mean that comets brought life to Earth. It just means that the primordial soup, or the soup from which the life originated, that soup was actually cooked probably by a comet, or a set of comets. So you could say that the comets are the chefs who actually brewed up the soup from which life basically originated. This is what we believe as of today. Now this is the mission, as I said, and you can see this is a spacecraft, and you have this this particular panel which is filled with aerogel, and it went through the tail of the comet, and it collected this material. And once this material is collected, this particular arm, it moves back, it retracts back, and it brings it inside this capsule. And this capsule is sealed, and it is refrigerated and sealed. And this capsule is basically returned back to Earth. Now, this is the actual thing. This is the actual capsule. You can see this is the object. This is the capsule inside which you store this this mesh with the gel. And in each of these pockets, you have a gel onto which this material was impregnated, or this entire gel was impregnated with material. Now, when I say there were a lot of materials collected, please don't believe that there were tons of material. It is just in grams, milligrams, basically. A very small amount of material only was collected. From this particular entire mission, the amount of material that we got was in milligrams. It is like 10 milligram, 2 milligram, 3 milligram, that much material only we got. And from this aerogel, they had to use a microscope to find out these particles, to isolate these particles from which they could take out the data. Okay, so this is the actual one. This is one piece that is still in Kennedy Space Center. They have displayed this, and this is the actual one which went. This is a proto hardware. This is the actual one which went and had come back. Then we have a deep impact probe. Deep impact is basically initially we took photographs of the comet's head. Then we said we'll go behind the comet, go through the tail, collect some material, come back. Now we have studied the images, we have studied the tail. Now we wanted to study the comet's head itself. So the deep impact was a spacecraft, was a mission where we studied a particular comet called as Temple 1. Now the mission here was to go send something or send a big blob which will go and impact, which will go and hit the surface of the comet. And then when the impact is made, that comet, when something hits the comet, it was supposed to break up small pieces of that comet, and it was supposed to throw this comet out. The portion of the comet, the pieces of the comets are supposed to be thrown out, and then study those materials which is thrown out of the head of the comet. So this is the actual photo of the impact. That is after impact. I'll show you one or two more photos. Basically, so the Stardust mission, deep impact mission is there. This is the major spacecraft. This is the mother craft, and there is this impactor. So the mother craft will go near to this particular comet. The impactor will be thrown. It will actually be thrown towards a comet, and this impactor will go and hit the comet. And when it is hitting the comet, that impact will create a crater, and it will throw out particles. And when it is throwing out particles, you go study those particles which is thrown out. That was a mission for impact, deep impact, and that was done in 2005. Now this was the probe as such. You can see this here, and you can see that this is the impactor. There are instruments on the impactor also, and this is the size of the impactor in comparison to a human. Now this particular photograph which you are seeing right now, this is actually, okay, this is the way it has gone. That is, this is the images from the impactor. That is, this is that comet's head. As I said, the comet is at a very far off distance. That is much beyond, much before the trajectory of Mars. So it does not have a tail right now. So that thing goes, the impactor goes and hits. That is what you're seeing right now. These are the actual images which came out from the impactor. And this is the image that we got from the mothership. So the mothership was standing there, and it was moving through, and then it was looking at this this comet as well as the hitting or the impact mission. And you can see this is the image, or this is the amount of dust or particles that came out when the deep impactor went and hit the comet. So when it went and hit the comet, a lot of dust particles, everything was thrown out, which was studied. This is another image. Okay, so many particles, so many ice crystals, so many protein particles, everything was thrown out, and that was studied. So then the first was to take a photograph, the second was to go through the tail, the third was to go impact, And the fourth one and very recent one is Rosetta in 2014. The Rosetta is a mission by ISRO basically. And the objective here was to go and land on the surface of a comet. Can we go and land onto the surface of comet? The problem of going and landing on the comet surface is that the comet itself is a very small object. You talk about the moon, you can land on the moon. Okay, the moon will not throw you off. The thing is that moon is having a good amount of gravity. The size is bigger, the size is huge. The moon has a very big size. And because of the size and the mass of the moon, moon has quite a good amount of gravity. The gravity of the moon allows us to stay on the moon. So if you go and hit the moon will capture you, the moon will keep you there because of the gravity of the moon. But these objects, that is, our comets are just 1 or 2 kilometers wide. Maybe the maximum, the biggest comet which we know of is like 40 to 45 kilometers wide. So it is only as very small. It is as big as a city or a small village basically. And because of this particular thing, the mass of the comet is very small. The gravity of the comet is very small. The moment you go and hit a comet, what happens is the comet's gravity is so weak that it will not be able to keep you there. Instead, you will hit the object, he'll hit the comet, and you will bounce off. You will just come back. It will be like throwing a ball onto a wall. The ball will not hit and stay on the wall. Instead, the ball will bounce back. The same way, the comet, if you go try to land on a comet, you will go there, you will hit the comet, and you will come back. You will just bounce back. Now, to avoid this, we devised a methodology. That is, we said we'll go with harpoons. You know, harpoons are things which are used to, pierce through things and keep it steady. So we said we'll go with harpoons. There are 3 harpoons. In this image, you can see that there are 3 legs here with 3 harpoons. So the idea was to go hit the object, hit that particular comet's head. The moment we detect the hit, the moment we say that I have just touched the comet, these harpoons will be fired, and these harpoons will see to it that it pierces through the head of the comet and it gets stuck there. And the harpoons will see to it that I am stuck onto the comet, or the harpoons will see to it that the comet is there on the surface, or the object is anchored to the surface of the comet. So this is what was the mission. And this is that particular comet which we are talking about. Don't ask me to read the name, it's a big name. Now this is the comet on which we are supposed to land, and we are supposed to land somewhere over here. And these are the harpoons which we are talking about. There is 1, 2, and 3. And you can see that these are the harpoons. These were supposed to be fired the moment it hits the surface, and this firing will do the job. That is what we had expected. And this is the object. So again, you have an impactor and you have a lander. Now it's not an impactor, it's a lander, and you have a lander and a mothership. This is a photograph from the mothership once the lander was detached from the mothership. Okay, and you can see the legs are all spread and it is ready to fire the harpoons. And this is the way it started to go, and it started to land. So it slowly moved from here to here to here to here. It is going to touch down, and from here, at this particular point, it actually touched down. It actually touched down at this particular point. So you can see that this particular photo is before the touchdown. You can see that 1518 this is the photo is taken, and in 1543 this photo was taken. You can see the impact here. You can see one hole here, one hole here, one crater here. All these craters were formed because of the impact. And from this photo, we understand that the impact wasn't as smooth as we thought. If it had gone and hit and all the 3 harpoons had fired, we should have only one hole. There should be only one hole here. And with that hole, in that hole, you should have seen the lander. But we saw that there are multiple number of holes, which means that probably the lander had bounced. Okay, so the harpoons probably did not work, or we do not know what it was. Then later studies were done, and we saw this. So this is how it was supposed to be, that the harpoons are anchoring. The later studies, we saw that the object was not here. It was supposed to be here, but later studies showed that it was not actually here. Instead, something had happened and it was thrown away somewhere. And it was actually like this. That is, we found it out here, somewhere here. Inside this, you can see one of the harpoons did not fire. So one of the harpoons is here. So out of the 3 harpoons, 2 harpoons fired properly, but the 3rd harpoon, either it failed to fire or the firing was not exactly at the time, or it was not done properly. So what happened is this object could not be anchored. Instead, it bounced. And 2 of the anchorings happened later, but it never went into the place, exactly the place where we wanted. And you can see that another problem was that if it had landed somewhere over here, it still would have been good, because the solar, you can see that it is sunlit area where you will get the solar panels to generate power. But what happened is it bounced and it went into this, it went into some area here where it is in the shade. So you don't have the sun, you don't have the sunlight here. It is in the shade of a mountain, so that it is not having enough sunlight to generate power. So we had to wait and wait until the comet itself turned. The comet itself twisted and turned, and at some point of time, this particular area got lit up by the sun, and the solar panels worked. It charged that particular mission, and some photos were returned later by this object. So it did not go as exactly as planned, but even from that partially failed mission, we could derive a lot of data. And you can see that this is one of the photographs which is sent back from the surface of the comet. And you can see that this is one of the harpoons. Okay, this is one of the legs and one of the harpoons. This is sort of a selfie taken by the cameras on board the lander. And you can see these are other photos which are taken from the surface of a comet. This is how it looks like on the comet. And all these things are, this is not, this rocks, this sand, this whatever you see here, they are all carbon dioxide or water ice. Basically, it is 95 to 98% carbon dioxide plus water together. And of this, 90% will be water ice. These are all photos which it had taken from the surface of the comet. As I said, the number of photos we got, or the number of data that we got, is not that huge because of this, the bounce back and the non-lit area of the comet, everything, the reduction in the power, etc. But still, it is a very successful mission. Now, from all these studies, what we have done, we now know that a comet has a nucleus, a comma, and a tail. There's a nucleus, a comma, and a tail. Nucleus is basically the head of the comet. Comma is basically the atmosphere around the comet, and then there is a tail, which is the elongation of the comma. The comma itself, or the atmosphere of that particular comet itself, is getting elongated, and the tail is formed. The nucleus is basically a solid structure, which is composed of rock, water ice, frozen gases like methane, ethane, carbon dioxide, carbon monoxide. Everything is there. Some ammonia is also there. They are called as there was a doubt whether it is dirty snowball or snowy dirt ball. That is, if you see those terms, it could either be dirty snowballs. It could basically be formed of snow or ice, and then dust could have been covered it, or it could be dust ball. It's a big ball of rubble or dust covered with ice. So there was a lot of debate between whether it is dirty snowball or snowy dirt ball. And from our recent observations and these missions which I was talking about, we now know that they are actually dirty snowballs. That is, they are composed of water ice and carbon dioxide ice. They are snow or ice, basically covered with dust. So it is basically dirty snowballs. And they have very low reflecting capacities and all those things. Apparently, nothing more than 40 kilometers is known till now. And the comma basically is what we talked about is the nucleus of the comet. And then there is a nucleus here, and then what you see around, you usually don't see the nucleus of the comet. We always see the comma of the comet, or the color or the brightness which you see is of the comma or the atmosphere. It is basically composed of when the sunlight radiates, or the radiation from the sunlight hits the nucleus, it vaporizes this comet and vaporizes the surface of the comet, and that vapors together around that comet forms the atmosphere of the comet, and that is called as a comma, and that comma gets elongated to form the tail. Now, any comet has got two tails. Any comet which you see around, it will have two tails. It has to have two tails. One is called as a dust tail, and the other is called as a plasma tail. So when solar radiation comes and hits a comet, the comet's atmosphere or the comet's surface and forms the atmosphere, and the comet's atmosphere itself there are particles which gets dissociated into ions. There are particles which stay as molecules. There are particles which get dissociated into positive and negative ions. So the positive and the negative ions, basically they form the plasma tail, which will always be bluish in color. Plasma tail has to be bluish in color. You know that plasma is usually spark. Any spark you see, they'll be in bluish in color because that is plasma. So this is the plasma tail, always bluish in color. And then there is a dust tail, and this plasma tail will always be straight. It will not be curved. The plasma tail will be bluish. It will be straight. It will be curved. It will not be curved. It will be straight and bluish in color. Whereas the dust tail will basically be a slightly curved tail with dust particles and water molecules, molecules of carbon dioxide, molecules of methane, ethane, propane, all those things. So the color of this particular tail, that is a dust tail, that is what helps us determine what is the molecule that is present inside the comet. Now, most of the comets, since it comes from the Oort cloud, they contain carbon dioxide and dicarbon atoms with having C2, carbon in the C2 state. And any comet having carbon in the C2 state, what happens is that glows with a green color. So almost all the comets that I have seen, almost 90 plus percent, 95% of the comets that I have seen in my life since childhood days, or most of them, almost 90+% of them are green in color. So appearance of green comet is not that of a, it is not that scarce. Even photos I will show you from 2019, whatever photos I have taken, there are very few comets which are not green in color. Green comets are the most common comets, or the green color is the most common color which you see for comets. And then you have the plasma tail with bluish color. So any comet has got not one tail, it has got two tails. One is a plasma tail, which is composed of ions, positive and negative ions, and that is the dust tail. Plasma tail is straight tail, whereas dust tail will usually be curved because of inertia. So this is the amalgamation of what the entire thing which I was talking about. There is a nucleus, there is a coma. So the nucleus is like 40 kilometers, but coma is very huge. Coma will be very huge. Then there will be a hydrogen envelope. Then there is the ion tail and the plasma tail, or the dust tail. Ion tail is straight, dust tail will be curved. So this is exactly what a comet is. And all this particular picture, the photo of the comet which we see here, is actually derived from all the missions, all the observations that were done till date. There are missions which took photograph, missions which went and sat on this thing, all those things together, whatever data is collected, entire thing is there in the about the structure. It is there in this particular figure. Now, another thing, as I told, probably this is the life of a comet, or one orbit of a comet. And somewhere over here is the, you can see this is the Earth's orbit. So somewhere over here is the the orbit of the Mars. So before the orbit of Mars, when it is near to Jupiter, Saturn, Uranus, Neptune and all, the comet does not have a tail because it is not hot enough to form the tail. In those regions, the temperature is not that high, the radiation or the heat flux is not high. So it cannot vaporize and form a tail. So what happens is, when a comet is coming towards the sun, when it reaches somewhere near to the orbit of Mars, and when it crosses the orbit of Mars, the temperature of the comet starts to build up, and it forms the coma, it forms the tail, and slowly the tail will start to grow. And then it reaches very near to the sun, where it takes this turn. During this turn, you can see that now in this particular location, you can see that both the tails are similar. That is, dust tail and the ion tail both are same. But as it takes this sharp turn, the dust tail gets a curve, whereas the ion tail is always remaining straight, and it will always be opposite to the sun. So it takes this turn, it takes the turn like this, and then it goes back. When it is coming, the tail is, the nucleus is in the front and the tail is at the back. Whereas when it is going back, the tail is in the front and the nucleus is at the back. It is as if the tail is moving in front and the nucleus is following the tail. So this is how it is. That happens because the tail is formed by the radiation from the sun, and the radiation from the sun will always see to it that the tail is pushed away from the direction of the sun. So when the comet is coming towards the sun, the radiation of the sun is pushing the comet in this direction, so that you feel that the comet head is at the start is moving in front and the tail is at the back. But when it is going back, what happens is, because the sun is here and the radiation is pushing the tail off, the tail is always away from the sun. That's all. There is nothing like it is in the front or the back. The comet's tail, you have to say that it is always away from the sun. So it so happens that when it is coming, head is at the start, head is in the front and the tail is at the back. And when it is going back, the tail is in the front and the head is at the back. Okay. So this is how it is. And this, as I said, the dust tail you can see in this particular photo of the comet. This is the direction of the sun, and the gas tail or the ion tail is exactly opposite to the sun, whereas the dust tail is in the curvature. It is curved. And this is one of the photos. Now I'll show you a few photos of the comet, and you can see that whatever you see right now, this is the coma of the nucleus, and the nucleus is not visible here. Nucleus will just be a tiny dot at the center, which is not visible here. What all you see here is just basically the atmosphere of that comet, or it is called as a coma. And this is the ion things there, and you can see the ion tail getting formed here. The back, you can see the ion tail, and so probably the sun is in this region. Sun is somewhere here, and this is the ion tail. The other tail, that is the dust tail, is not yet formed. So at this particular time, when it is photographed, This particular comet was somewhere near to the orbit of Mars, or maybe in between Mars and Earth. This is another comet which has a very profound tail. And what happens is, I'll tell you this also. Every time a comet comes towards the sun, it is actually ejecting out material, right? From the nucleus, a lot of material is getting gasified and is ejecting out material, which means that every time it comes towards the sun, it is losing material. It is basically getting a lot of material out. So when a lot of material goes out, the size of the comet becomes smaller and smaller and smaller as and when it comes to the sun. So Halley's comet, if you take in 1503, when it came, it would have been very bright. The next time when it comes, it will have been slightly lower brightness. The brightness also comes down, or the amount of gas and dust it produces becomes smaller and smaller and smaller. And probably the next time when it comes, we may not even see a tail, because all the material that can evaporate would have been evaporated and left the comet by now. So every comet, when it comes first, that is the time when you see it brightest. And every time it comes and loses a lot of material, so the next time it will be smaller, like that it goes on. And these are all spectacular photos of comets. Every time there are at least minimum two things are there, two tails are there. And you can see that almost all of them, except for this one, has a greenish tinge, right? And this is another comet with the tail so profound that it is actually moving across the entire sky. Now, what happened is, in this particular case, what happened was, every time, you know that the comet's tail is formed from the sun. So there are certain times in history, or maybe every 12 years, there are certain points where the solar maxima is there. That is, sun is very active. Now we are passing through a solar maxima. Now there are lots of sunspots and solar eruptions. Everything is happening right now. We are moving through a solar maxima this year and next year. So when solar maxima happens, the sun becomes very unpredictable. The sun will give out a lot of chunks of materials every now and then. So, so what happened is, every time the sun is giving out a solar wind, the tail gets out. A large amount of tail is coming out. So you can see that there is one solar maxima here, solar wind. There is another solar wind here, another solar wind happened here. That is why the tail is something like this. So every bit of this one solar maxima, this is another solar maxima, this is another solar maxima. So many solar flares has happened, or solar wind, or maybe an eruption from the sun has happened at every point here. Now this is another one which came in 2003, which has a very, very long tail. Again, this is green. This is another one. This is another one. These are all taken from this particular picture is taken from outside the Earth, and this was probably taken by the Hubble. Now this is another comet. This is called as a comet Ison. You can see that in this particular image, this is taken by a solar observatory. Basically, solar observatories are observatories or spacecraft has gone beyond the Earth's gravity field, and it is positioned at a place where we can study the sun solar activity. So those telescopes which are looking towards the sun, those missions are also used to study the comets. And whatever you see in the background, some flow that is happening, sun is here, sun is at this particular location, and all those dots are actually stars. And you can see that the wind, or the materials that is coming out, this is called as a solar wind. That is, sun is giving out all these particles and material. And you can see that in the solar wind, the tail of the comet, if you take the comet NK, you can see that the tail is wiggling. The tail is wiggling because of the wiggle in the solar wind that is coming. You can see that the tail is just flapping or wiggling. And that is because of the solar wind, and the tail is caused by the solar wind itself. Okay. Now, in this particular case, it actually will lose the tail. You can see that it actually loses the tail. See, I'll just play that once more. You can see that somewhere over here, it will lose the tail. That comet loses the tail when there is a huge wind. A huge solar wind comes, it washes away that tail, and then the tail again reappears. This is probably for the first and the last time we have seen this activity. This particular case, this activity of the comet losing its tail to the solar wind, and the solar wind again reforming the tail, was for the first time and probably for the last time we have seen it up till now. We have never seen such an event till date. So this is an actual image where a comet actually loses its tail. Now the orbit of the comet, as I told, it is a very, 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 very elongated orbits are there. So it actually passes through the entire solar system and comes back. It is much longer than the orbit of Neptune. Also, they are trans-Neptunian objects, as I was pointing out. Now there are short period comets and long period comets. Short period comets are comets which it's like Temple 1, where it passes through, it would have originated very near to Neptune only, but once it comes here, because of the gravity field of Jupiter, Saturn, all those things, what happens is its orbit also gets changed. And there are comets which are very short period orbits, like Temple 1. It goes around in a very short time because it is moving from the Earth's orbit to Jupiter's orbit and coming back. Okay, so these are short-term comets, whereas Halley is a long-term comet. And there are comets which comes and we do not know when it is going to come back. But when it is going to come back, like the one which has just passed us, that we still don't know when it is going to come back. We estimated it to be 50,000 years, but that is a very, very vague, or it is not that precise a number. It is much more than 50,000 for sure. So there are short period comets and long period comets. And usually the short period comets does not have bigger tail, but long period comets are very bright in tail. Now this is the Kuiper belt I was explaining about. Around Neptune, just after Neptune, there is a Kuiper belt, and Pluto is an object in the Kuiper belt. But probably if Pluto was kicked off, or Pluto was given a jerk, Pluto was given a kick, Pluto itself would become a comet. Pluto is basically the member of the Kuiper belt, which has a lot of carbon dioxide and water in it. So probably if Pluto was not a planet, or I mean dwarf planet, or Pluto was had got a jerk or a kick, it would have just come towards to the sun and it would have formed a comet. Now Oort cloud, again, you can see that this Kuiper belt is a disk. It is a disk. It's a disk of materials or comets basically. Whereas beyond the Kuiper belt, there is something called as Oort cloud. It was defined by somebody called as Jan Oort. Jan Oort is still alive even now, and he proposed it very recently. So this is the Oort cloud. This is the structure of the Oort cloud, and which is a spherical body. It is like a cloud around the solar system, and from the Oort cloud is the location where the comets are residing, is what we understand, what we know of as of now. It's like, you know, it's like 1 light year from the sun. This diameter is like 1 light year, which means that from the sun, the sunlight will take 1 year from this particular point to reach here. The light, where it is traveling at 3 lakhs kilometers per second, which reaches Earth in 8.5 minutes, will reach this Oort cloud basically something like in a year's time. So that is that much is the distance from the from us, basically, you can think of. And comets are things which pass through all the regions of the solar system. Now comets and meteor shower, we know that the comet's tail composes of a lot of dust and rocks, rocky bodies, some gases, all those things. So it so happens that at certain points of the year, Earth will pass through some of these tails. The tails are left behind. So the tails are there. The tail is there of any comet. When it goes, the tail is left behind, and the tail is left behind to cool. So the tail, what is coming out of the comet, will remain in orbit, and in that defined orbit, that tail gets condensed later on to form rocks, small rocks. So at certain points of the year, when our Earth passes through this tail or the trajectory of these comets, what happens is the Earth's gravity will pull these small rocks and bits and pieces towards Earth, and it forms something called as a meteor. You would have seen some meteors move across the sky. So these meteors are formed from basically from the tail of comets, and like November 14, 15, 16, February 20, 21. These are April 14, 15, 16. These are the dates where you should be looking up at the sky, and these are all named after some constellation like Perseid meteor shower, Leonid meteor shower, Orionid meteor shower. So you can just look up at the internet and you will see that there are certain times of the year when you should look up at the sky, and you will be able to see these meteors, which are basically derived from the tail of a comet. You will see it fall down or burn out. Okay. Now I'll show you some of the photos which we had taken since 2019, which we had taken with basic DSLR. That is the DSLR cameras you have. With a basic camera, all these photos has been clicked from Trivandrum, basically. This is a comet in 2020, which was called as Neowise. This was very bright. It was actually very bright during the COVID pandemic lockdown period. So this was one object which was actually a naked eye object, naked eye visible comet. You can see there is a comet here, and the tail is also there, which we had captured. Okay. Now this is the detail of that photo. You can see the comma of this comet, and there are tails, and all these NGC, whatever I have written, they are all galaxies, small galaxies, which which has also come in that particular photo. So now here you can see the tail. There is the tail is there here, and the green color comma. This is the comma. Nucleus will be very small, which we'll not be able to see in this photo. And this is how it moves actually. What you see in the background, this photo is composed of almost like 100 photos. Okay, 100 photos are played one after the other. It is animated, like you make your animation movies. What you do is you take hundreds of photos, you stack it one over the other, and then animate it, flip the photos. Now this is a GIF file which is formed like that. And in this particular case, you can see that this entire photo, which you see in 4 or 5 seconds, this photo comprises of photos taken over something around 6 hours. So from night 6 o'clock to early morning 6 o'clock, we had photographed it, and the photos were taken over 12 hours time, but the amount of data that is there, it comprises of 6 hours. Okay, so the photos were taken maybe like 10 minutes interval. We had taken photos, and those photos were stacked over one after the other to get this image. So this is 6 hours image taken over 12 hours time frame and then animated. So all the stars, you can see the background things, the dots you see are stars, and against that star pattern you can see the this thing move, right? You are seeing the comet move, and you can see that in this particular image, the comet's tail is in the front, in the direction of the comet's tail is in the front and the head is at the back. So from this image, from this particular thing, you can identify that this comet is not coming towards the sun, it is actually going away from the sun, right? So this is how you decipher a comet's trajectory. Now this is another comet. This was probably the only comet which we saw which is not green in color since 2019. This had an orangish tinge. This was called as Comet 2021 A1 Leonid. It was in December 2021. And this is the Leonid's motion. You can see that it is very faint or very slow moving. This is again a 6 hour image in comparison to the Neowise that we saw last. This is a very slow moving comet because it is very far away from us now, and this again it is moving away from us. That is why the tail is in the front and the head is at the back. It is moving, it's as if it is moving backward. So this is also an image of a comet which is moving away from the sun. This is another comet which is called as Iwamoto. Iwamoto was a very faint comet of February 2019. You can see that it is like a star. It is much smaller than the star. Regulus is the star which we call as Magam. We call Magam, this particular star as Regulus as Magam in Malayalam. This is one star which you can observe at around 9 o'clock. 9 o'clock, if you see towards the east at around 45 degrees, you will be able to see Regulus. So from with that, you can compare the size. With respect to Regulus, this comet Iwamoto is a very small thing, but again, it has got a greenish tinge. The tail was not that visible. Now, this is another comet which is called as Swan. That is a very faint comet. It was not even visible with a telescope. Again, this greenish tinge. How do you understand that this is a comet? First thing is it has got a greenish tinge and it moves, but this comet does not move much. So then what you do is you take an inverted image, and you can see that with respect to the other stars, you get a different hue of that particular thing, and this is how you actually discover comets. Now, if you take and all these comets, if you see, almost all these comets has been discovered by individual hobby astronomers, because they click a lot of photos, they compare it, and you can also take photos and try find out a comet of your own. And if you find the comet, if you are able to discover a comet, that comet can be named by you. You can propose the name of the comet. For example, the Swan itself is a name which was proposed by the person who discovered that comet. Iwamoto, like Iwamoto is the person who discovered the comet. He put that name, his own name to the comet. Like that it goes. So try shoot photos. You may be lucky one to have a comet named after you. Okay. This is another comet, but again it is very faint. You cannot see that specifically in this, but it is very faint. It is there over here. And the comet that has just passed us and has gone out. This is first of all, what I wanted to tell you is somehow, even though, as I said, some 9 comets has passed us since 2019, this particular comet has got a lot of attentions. We also don't know why. There is nothing particular about this, whatever comet has passed through. It's a very simple comet. In fact, a very small comet also in comparison to whatever we had shown you, the photos I have shown you. In comparison to Iwamoto or in comparison to Neowise, this is a much fainter comet. Its green color is a normal color. it's not unnatural to have a green comet. It's quite, in fact, in contrary, it is quite natural to have a green comet. Green comets are very common, and this is the size of the comet in comparison to one of the stars. Okay, this is one of the stars, and this is the size of that comet which you are expected to see. It was never naked eye visible. Papers were telling it was naked eye visible. It was never naked eye visible, and it was not expected to be naked eye visible. Also, we tried countering this, but I don't know. It somehow got a lot of celebrity status. I'm not sure how it happened, but this was what we saw from Trivandrum. And this is actually another photograph where an aircraft crossed our frame. This is an aircraft crossing our frame, and when we are taking the photo, and these photos are, whatever photos you are seeing now, they're all 20-second exposure. That is the light from this comet, the total amount of light, that is 20 seconds. For 20 seconds we are taking that light and we are capturing it. That is the photos, the camera shutter will be kept open for 20 seconds and the images click. So in that 20 seconds, the aircraft has moved from here to here. That is what you're seeing right now, and that is how this photo is taken. And this is the zoomed view of that entire photo, and you can see that the stars are all shaken up because somebody has walked around. When we are taking the photo, somebody has walked around, and that give a shake to the photo, and that is why it is a slightly wiggled. Now this is the motion of that particular comet. Whatever comet, this is again, this is 8-hour data. In 8 hours it has moved from here to here. Okay, can you see that? From with respect to the background sky or background stars, in 8 hours it has moved from here to here. It is like the hour hand of your clock. You will not feel that it is moving, but if you do this animation, or if you take photos at every 10 minutes or 20 minutes and then flip, you will see something like this. So the comet moves. So when somebody tells you that the comet is moving very fast, no, it is not moving very fast. It is moving actually very, very slow. Okay, this is another thing which was discovered by some people, and some comets. This is the star. This is the comet ISON, which was visible in 2000. I think in 2013. Just visible in 2013. I'll just flip through all these photos. This particular comet. Okay, this is what I was telling about the comet's ISON. The basic thing was, this ISON is this particular comet. It came very close to the sun, and this particular region is the atmosphere of the sun. So it has gone through the atmosphere, and we were not sure what to expect. We were not sure whether it is going to come out of the atmosphere or not. So there was a particular program which was going on, where we sat and observed how it is going to come and what is going to happen. There was a camera which was looking at that event, and you can see that the comet is coming. It is going through the atmosphere of the sun. It goes very, 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 very near to the sun. We never expected anything to come back, but somehow something came back. Something came out. It actually went through the atmosphere of the sun, which is very, very, very hot. But it is so hot that even iron will liquefy. Iron is not supposed to be existing in the solid state. It will liquefy, and most of the light metals like sodium and potassium and all would have vaporized also. So to that temperatures, this particular thing has gone into, but it has come back. But what came out, we expected, seeing this image, we thought it is something solid has come out, and we were all surprised at it. But it was not a solid piece. It was actually a gas bubble only, which came out and then diffused out. We still have no explanation of how or why a gas bubble, a globe of gas, could come out like this from the sun's atmosphere. It went in as a solid piece, but came out as a gas and then dispersed off. So this is the story of ISON. We are still analyzing these images or the data that we got there, and people are still hypothesizing how it is possible or why a comet behaved like this, how something could go into the sun's atmosphere and come back and then get diffused off. One more thing which we should show, or which we should be talking about during when we talk of comets, is the case of Schumacher-Levy. Schumacher-Levy actually tells us how Jupiter and Saturn is helping the Earth remain as it is. Schumacher-Levy was a comet which was bound towards the inner solar system from the Oort cloud, a big comet. And as it came near to the Jupiter's immense gravity field, it actually captured that comet, and it actually absorbed the comet. So the comet went and hit Jupiter. So it shows us that the Jupiter and Saturn, these two big bodies, which is circling around or orbiting around the solar system beyond Earth's orbit, these things, they actually clean or they actually captures a lot of comet. It actually captures a lot of comet and saves us, or saves the inner solar system from these comets coming and bombarding us and maybe destroying us like the dinosaurs. You know that the dinosaurs, the mass extinction of these dinosaurs, or the Jurassic world or Jurassic era or Cretaceous era, the mass extinction was caused by a comet which came and hit, or an asteroid which came and hit Earth. So Jupiter and Saturn are the two bodies which helps keep the inner solar system clean from these comets. And you can see that this is the Schumacher-Levy. It broke apart. It broke into smaller pieces and went and hit Jupiter. And you can see these are the scar marks, or this is how the Jupiter was. And when it hit Jupiter, this is what happened. And believe me, the size of this particular circle over here, it can actually engulf more than one Earth. The size of this hit mark is so huge that you can put one Earth into this. More than one Earth can actually fit into this diameter. So it is so huge. So it is helping us, or the Jupiter has actually helped us from avoiding such big chunks of rocks which is thrown towards us by the universe. Okay, so these are the impact points. Why Schumacher-Levy became so interesting is that we could see this event live. We could see it break apart and hit. Hubble Space Telescope was able to capture these images, live images of this, and it was transmitted live to Earth. And there is one more thing which we at ISRO are very keen in telling, which is basically the siding spring. There was a comet called as siding spring. This is a siding spring comet, and there is Mars over here. So when this siding spring comet passed very near to the Mars in 2014 October, it was the tail of this comet was actually hitting Mars. The tail of the comet was hitting Mars, and the Mars was passing through the tail of the comet. So the problem was that there was our Mars orbiter mission, or Mangalyaan mission, and NASA's MAVEN. These two spacecraft were there, which were circling around Mars at that time. So this event happened in 2014 October, when we predicted that the tail of the comet could come and hit. It was passing through Jupiter, passing through the Mars, and around Mars we are having two satellites. One is MAVEN from USA and Mangalyaan from India. So if the tail hits any of these satellites, the satellites would get damaged. Okay, the satellites will go weird because it is dust particles. It is like bullets coming and hitting you. So there is a possibility of damage. So then we discovered this comet. We predicted its path. We predicted when it is going to hit. When the tail is going to pass through, or the mass is going to pass through this tail. And what we did is, and this was the size. Okay, this is the size of the comet. It's not that big a comet, but this is a city. Comparison to city, this big. So it is quite big. So what we did is, when this is how it was. This is the animation. Basically, when the comet was passing through here, and the comet's tail was actually hitting the Mars. So what we did is, all the satellites which were there around this, which was passing around, or which was orbiting the Mars, we took Mars as a shield. So the orbital parameters of the satellites were changed. The orbit was tuned such that when this tail hitting event is happening, the satellites are behind Mars. So Mars was used as a shield. Mars was used as a protection to protect the satellites from hitting the particles from the tail of this comet. So this was one event where we tried this maneuver for the first time. We got, not only India, NASA also got for the first time an event where some maneuvers can be done and something can be tried, like you see in movies, right? Like you see in movies where some Armageddon sort of a movie, when something is going to hit something you do. It was a situation like that where you were using Mars as a shield to protect our satellites from a comet. But this you cannot ensure that every time we'll find a comet which is going to do this, and that this event also told us how harsh the environment outside the Earth is, because Earth's atmosphere would have protected us from this event if we were on Earth. But if you were actually on Mars, where there is no atmosphere, some of these rocky materials would have fallen on your head, right? So that is how hostile the space is outside the Earth's atmosphere. So with that, I am stopping my presentation here. Now, if you have any questions, queries, maybe we can take that. I think I was on time. Yes.
Please come into the camera, sir.
Just a
so
minute.
that yes. Thank you.
I'll do one thing. I'll just join from one more. I'll join from my phone also. So that
yes.
the slides also I can just a minute.
Yes, yes, yes. Okay. Children, get ready. Are you not inspired by hearing all this? Anyway, I am excited. So please be active in the actively participate. And I can share you one thing. I saw this 1986 Halley's Comet. It was a wonderful sight. I could see from an observatory. Okay. Thank you. We'll wait for sir. He's a young scientist who has inspired all of us. So we will wait for him. He will join now.
No, you can start asking questions. I'll join anyway. I'll just
yes. Children, yes. Start one by one. Okay. Namshivaya. More opportunities are waiting for you. We are planning so many things for you people, for what you call AstroClub members. So please ask. Namashivaya. Yes, you can introduce yourself. Yes.
I am D. Devasai. Sir, I also see the comet Shiba 20233. That comet I take a photo of the comet.
Okay, very good. You took a photo of the comet. Yes. So if you have that photo, if you could share, we could all enjoy it.
Okay, sir. I will share it, sir. Sir, my doubt is why the comet has two tails.
Why?
The comets have two tails.
Yeah, why the comet has two tails? Can you see me now? I think I'm visible now, right?
No, sir. No.
Yeah.
I think Julius, you can. Now, yes.
Yeah. So why comet has two tails? Okay. As I was explaining earlier, I'll just go to that slide. What happens is when the comet is that tail is getting formed. If you take here, you know that I have told you that the comet is having a nucleus which is composed of solid ice, carbon dioxide ice, water ice, and dust particles. Dust means the dust is what the dust is basically composed of the dust that has collected from all around. That is when the way it is going, when it is moving, it is collecting all this dust. It is getting dusty. So when sunlight hits this nucleus and it starts to boil or it starts to sublime and gas is formed, certain compounds like water or carbon dioxide, they will remain as water and carbon dioxide. But there are certain molecules like ammonia, for example. What happens to ammonia is ammonia gets ionized. Ammonia gets into ionic states, that is NH4 plus ions and one electron will be jumping off. So these type of reactions takes place, or decomposition takes place and plasma is formed, or basically ions are formed. Positive and negative ions will be formed. The dust is different. Dust is not charged. They are neutral particles and they move by the principles of inertia basically. Whereas ions will be charged and ions will move with electromagnetic forces. So sun is also radiating a lot of gases which are ionic in nature. So because ions respond to ionic gases, they form one tail, and the dust which does not, or neutral particles or neutral dust like carbon dioxide and water particles which does not respond to electromagnetic forces, they respond basically to the inertial forces. So because of the inertial forces, it curves, whereas the other tail, that is the dust tail gets curved, whereas the particle tail or the gas tail or the ion tail, because it is responding to the electromagnetic forces, they respond to the electromagnetic forces and they form another tail. So that is how minimum two tails are formed. It could be more than two tails. The dust particles itself is getting dispersed off, or the ejection is in different fashions. So ion tail and dust tail will, when the curvature of the orbit is not very huge, or the inertial forces are not huge, then the dust tail and the gas tail will be seen as one. It will be in the same direction. Whereas when the curvature of the trajectory is high, that is when it is near to the sun and all, what happens is because of inertia, the gas tail will, or the dust tail will curve, whereas the gas tail or the ion tail will not curve, it will be straight line. So that is how two tails are formed. Hope I was clear.
Okay. Sir, can I share the screen?
Yeah, of course, you can share the screen. I'll also be happy to see. Okay, so this was a photo you took.
This is the photo I took
Okay, you have taken this photo with, how did you take this photo?
with my telescope.
With your telescope. Okay, with the telescope which I am seeing behind behind you.
Yes, sir.
Yeah, okay. The photo is good. Next time when you take, did you take it with your mobile camera onto that, or did you attach the camera itself onto the telescope?
Yeah, I attached to the mobile camera.
Okay, you attached to the mobile camera and took the photo. Okay, the click is good. One small thing is, you can see the color also here. The thing is that this much curve that this is actually shows that there is a small wiggle. That is, when you take these photos, astrophotos, when you take it, see to it that you don't shake either your hand, or it is always better that if you can try to mount your camera or your mobile phone, you use a tape, double-sided tape or something, and you try to attach it. Cameras you can easily attach because you get adapters. You can use a PVC adapter, PVC pipes itself to attach your camera. But mobile phones and all, when you attach, you don't hold the mobile phone in your hand and click photos. Instead, next time when you try taking a photo, you try to fix it and see to it that nobody walks around. If you are on a terrace or something, if somebody is walking around, or if a big vehicle is moving near to your home, what happens is the ground will slowly shake, and because of that ground shake itself, this photo can wiggle. I can see that there is a wiggle in the photo. The photo is good. The photo is absolutely good, but you can avoid that wiggle also. Okay, was I clear?
Yes, sir.
അധികം കുലുങ്ങാണ്ട് നോക്കണം, ഒട്ടും കുലുക്കാൻ പാടില്ല. ഇവൻ ആൾക്കാരെ നടക്കരുത് അതിന്റെ ചുറ്റുവട്ടത്ത്. അപ്പൊ കുറെ കൂടെ ഷാർപ്പ്, കുറെ കൂടെ നല്ല ഇമേജ് കിട്ടും.
Sir, I took the photo in our ground.
You took the photo
In our temple ground.
Okay, from the temple ground. Okay, അപ്പൊ ഈ ടെമ്പിൾ ഗ്രൗണ്ടിലൊക്കെ പ്രശ്നം എന്ന് വെച്ചാൽ കുറെ പേര് നടക്കില്ലേ, or some things may be going, some shake, എന്തോ ഒരു ഷേക്ക് പറ്റിയിട്ടുണ്ട്, ഇവിടുന്ന് ഒരു ഷേക്ക് ഉണ്ടായിട്ടുണ്ട്. Okay.
Okay, sir.
So next time again you should try. I would suggest that you try using the telescope. That telescope is a very good telescope. You can try using it for capturing other objects like Orion Nebula, which is available now. Andromeda Galaxy ippodilla. Andromeda Galaxy maybe 2 or 3 months later in the morning sky, early morning sky, you can see. Andromeda you can try today itself if you want. Okay.
Okay, sir.
Thank you for sharing. Have a nice day. Yeah. So shall we move on to the other question? You, sir, is there any that comets have chances to become the satellite of Jupiter? Yes. The question, the answer to that question, which Advaid, I think Advaid has posted this question.
Yes, sir.
Yeah, Advaid only has posted the question. So thank you, Advaid, for that question. I hope that the question is whether any comet can become the satellite of Jupiter. Of course, the comets can become satellite of Jupiter, and there are many events where any object like Jupiter, because of its immense gravity, it can actually capture some of these comets, and it can make the comet a moon of Jupiter. So the Jupiter's moons are classified basically into two. Any object's moons are classified into two. The moons that are formed along with the planet itself, and the moons which are formed or which are captured objects, like comets getting captured or asteroids getting captured. Now these moons, they are having different characteristics. Basically, when a moon is formed along with the planet, when a moon of a planet is formed along with the planet, the moon's orbit will be almost parallel to the equator of the planet. That is the case of our moon. Okay, the moons which are formed along with the planet will have a trajectory which is near parallel to the equator of the Earth, or equator of the planet, or it will be in the equatorial plane basically. Whereas the moons which are captured by the planet, it will not be in the equatorial plane, it will be in an eccentric plane, or it will be in a with the inclination only. The object will have a trajectory which is inclined to the equatorial plane. Also, such captured objects will have a special trajectory which is very much different from the trajectory of the moons that are formed along with the planet. So in case of Jupiter and Saturn and all, of you see out of the 60 plus 65, 67 or 70 moons that Jupiter has, very few moons are in the equatorial plane, which suggests that almost more than 60 to 65% of the moons of Jupiter and Saturn are basically asteroids or comets which are captured by the planet. So even now that process is happening. This is about the satellites. There are other objects for Jupiter and Saturn. There are other objects which are captured by the Jupiter and Saturn and which are not in orbit to the Jupiter, but they are moving with respect to, or they are captured by Jupiter and they are moving around the sun, but very near to Jupiter. Those objects are called as geeks and trojans. There are objects called as geeks and trojans. You can just Google it out. You can see if you type trojans of Jupiter or geeks of Jupiter, you can see the details of such objects also. So yes, the answer to that question is yes, Jupiter can capture, and there are events where Jupiter has captured many comets and asteroids from the asteroid belt and has made those objects either its geeks or trojans or its satellites.
Thank you, sir.
Yeah. And then Ayush has asked whether any comet has collided with the sun. Of course, many comets collide with the sun, but sun is such a huge body that we don't say it collides with the sun. Actually, sun will eat up that comet, or sun will absorb that comet. So yes, a lot of comets have collided with the sun, and lots of comets will again collide with the sun. And one photo I showed you where it just missed colliding with the sun. Instead, it grazed through the atmosphere of the sun. Now Arjun has asked what happened if a comet hits the Earth. Of course, that question is a $1 million question basically. What will happen if a comet hits the Earth? There are many possibilities. One is that if the comet is a very small comet, the size of the comet is very small, there is a possibility that it comes and the atmosphere itself will burn it down. That the atmospheric friction will see to it that it burns down. Another possibility that it becomes very big. If it is a big comet, on the way to the atmosphere, through the atmosphere, that comet could explode. And the explosion will lead to the comet becoming smaller and smaller pieces, creating a lot of small explosions all around the world. Another possibility is that the comet comes and hits the Earth. A big comet comes and hits the Earth, then the Earth's crust itself could destabilize. Lots of things can happen. Actually, this is one doomsday scenario. One of the scenarios where the destruction of life or the destruction of the environment that we see on Earth is a possibility where a comet comes and hits. And to avoid such cases only, we are in the process of finding out a way to deflect such comets. And you would have read in a very recent past, we have done an experiment called as DART. NASA has done an experiment called as DART mission, where like the Stardust, like the Deep Impact mission, a big object, a big ball of lead was pushed, and it was actually collided. It was actually bombarded with an object, with an asteroid, in an attempt to change its trajectory. So there are missions, there are scientific missions which we are planning, which we are in the process of designing, where we are trying to deflect off the trajectory of a comet or an asteroid which is coming towards Earth. So that type of research is also going on, but it is not that easy. It's not that straightforward.
Excuse me, sir. Excuse me, sir. I think we will, 1 minute. We will finish the session by 12:45, sir.
Okay,
and remaining questions, we will prepare a Google sheet and put it in the group so that they can enter in that question.
That can be done, ma'am.
That is okay,
only,
no?
Yeah, only 2 more questions are there now. So
yes.
we'll answer those and we'll stop.
Okay, fine. Thank you.
3 more. This is the 3 questions we'll answer and we'll stop. Okay. The first one is Vishwanath M. Warrior. Why C bar 2022 is green in color? This I have explained earlier itself, that if at all a comet is having a dicarbon, that is carbon or C2, carbon in the C2 form, or even methane and ethane, those gases glows with a green color. Those gases has a greenish tinge when it glows. It emits green color, and that is why that object is green. So it means that this object is having methane, ethane, or carbon in the C2 state. And that is why if you see Neptune and Uranus and all, they are having a greenish tinge because of the methane and ethane that is present there. And comets usually glow green when they are having carbon-based particles in it. And Sri Lakshmi has asked, how can snowball be present in space without water content? That's what I told. As per the theories of hypotheses that exist about the formation of the solar system, Earth and terrestrial planets, Earth, Mars, Venus and Mercury are the places where you don't expect water to be. Almost all the water content, the major share of the water content of the solar system is in the trans-Neptunian objects. That is, objects beyond the solar, beyond Neptune. So these objects has a lot of water content, and those water only has come through comets to Earth. So Earth, if you see the content, though we see that the surface of Earth is filled with water, the total composition of Earth, if you take, not even 1% is water. Less than 1% only is water. The rest is iron, or many heavy materials are the heavy metals are the iron, iridium, and then you are having a lot of silicon. All those things are there, but water is very scarce actually on Earth. And the amount of water that is available in the outer solar system, basically beyond Neptune, is very huge. So they are actually snowballs. So the content of water is more in trans-Neptunian objects, basically. So Mohan Murari, okay. Sir, now it is clear that there are comets in our galaxy, in our solar system, basically. Are there any cases that comets are there in other galaxies? Of course, comets will be there in other solar systems, not even in galaxies, in other solar systems also, all comets are there. If yes, can they travel our galaxy? Can it be dangerous? We have no idea about any comet which has come from one galaxy to another, because the galaxies are very much away from each other. But we have evidences of at least 2 objects which has come from the other solar systems. That is, from other solar systems or other interstellar space, as we call it. From the interstellar space, we have objects which has passed through the solar system. There was an object called as Anumaya, which has passed just 2 years before, and there was another object which has passed last year, which has crossed the solar system, and the trajectory shows that it is not, they does not belong to the solar system, but they have come from interstellar space. It has passed, it has crossed through the solar system. So can it be dangerous? Of course, it can be dangerous, but the possibility of such an object coming and hitting us is very small. The last question which I'll be answering today, it tells us, it is asking, it is said that comets brought fundamental particles of light to Earth. Then why did it hit other planets and incorporate fundamental particles of life to it also? To answer that question, of course, it is not only to Earth. The fundamental particles of life or water would have come to Mercury, Venus, Earth, Mars, everywhere. If you take Mercury does not have an atmosphere, and it is too close to the sun, that the temperatures there is so high that you cannot expect water or these basic molecules like methane and ethane to exist on Mercury's surface. It will just vaporize and go out of Mercury. The second possibility is on the Venus. Venus has very thick atmosphere, basically composed of carbon dioxide, and because of the carbon dioxide, there is something called as a runaway greenhouse effect, because of which the temperature of the Venus is increasing day by day. Slowly, the temperature of Venus is increasing, and the surface of Venus is almost at 450 degrees Celsius right now. At that temperature, water itself will dissociate. Water does not exist as H2O, it dissociates into hydrogen and oxygen, and any amount of water that is there on the surface would eventually evaporate. It will evaporate in no time, and most of that particles, before it gets to the atmosphere, it would dissociate into hydrogen and oxygen. So then there is no chance there also. Earth and Mars, yes, Earth and Mars can have water content in there. Earth, you know, you have water. Mars also, we now know Mars still has water, as well as some basic particles of basic protein particles, everything is there, probably which has come from comets only. So Mars has carbon dioxide, Mars has water in its north and the south poles. Now, the particular case of Mars is that the Mars is much smaller than the Earth, and the Mars has lost its gravity field. I mean, not gravity field, the magnetic field, I'm sorry. Mars has lost its magnetic field. Earth has a huge electromagnetic field. It has a magnetic field which protects the Earth's atmosphere from the solar wind. Like the case of comet, the comets, I told, the comets coma, or the atmosphere of the comets get washed away in the solar wind. The same way, Earth's atmosphere also should get washed away by the solar wind. But what happens is, Earth is having a huge magnetic field, because Earth is having an inner iron solid core, and then outer core is molten iron, and because of this structure, Earth has a huge magnetic field. Because of the magnetic field helps us in deflecting the solar wind. The solar wind is deflected around the Earth's atmosphere, and so the Earth's atmosphere as such is protected by the magnetic field of the Earth. Unfortunately, somehow the magnetic field of Mars also had a magnetic field, and we have evidences that Mars had flowing water and probably life sustaining particles also, life originating particles also. But eventually the Mars's magnetic field was lost, because of which the atmosphere of the Mars was washed away by the solar wind. And because of this event, Mars does not have an atmosphere, and when there is no atmosphere, thick atmosphere, or the pressure of the atmosphere is not 1 bar, what happens is water will just boil off. So that is why Mars is not having. Basically, what I meant to say is, to answer your question, comets has not just brought water to Earth, it has brought to all the other planets, but because of the situations there, it could not hold that water. And one more thing which you should think of is, just because the ingredients are there, there is a soup in which you are having proteins, you are having glycine, you are having water, you have salt, all these things, it does not mean that life can originate. It only means that what I meant was, comets had created a situation where life could originate, where life could kickstart by putting all the ingredients into that bowl of soup, or the soup. It has put all the ingredients, but to create that soup, there should be some event, maybe a lightning spark, maybe some other churning effect, something has happened which has kick-started that process of life, which we still don't know what that was or how that was. But what comets did is, comets created the correct environment, or the correct ingredients that was required for the life to kickstart was created by the comets on Earth. That is what was meant in the presentation. So I think, ma'am, we'll stop there. I think it is 12:45.
Yes, correct. Exactly. Om Amrideshwari Namaha, Namah Shivaya. On behalf of AstroClub, I really thank you, because you are so busy. I couldn't see him, but I talked to him over the phone, and my student Sangeeta just directed you, and you just helped us. It was a wonderful session, actually. And
you,
all our AstroClub members are so lucky to have such a lot of fresh information from a young scientist like you. At this young age, you have aspired so much knowledge. So we are so proud of you. And actually, there are so many projects from his side. He has suggested that I will just put it in the group. Anyway, I guess you all have spent almost 2 hours in the busy schedule. Sunday is the only day he gets off. Then apart from that, yes, there are so many students actually 500 students are there because of the exam, and nearly 160 members have joined. Still they are joined, and so many principals are there in this line, so they are also very much aspiring to hear more from you. Thank you, sir.
Thank you, ma'am. Thank you so much for calling. I am sorry that I was not able to talk to you before, because I always
no problem. No problem.
I'm late, and then
yes, one technical team is there, head by Julius. He's also there with us, helping all this technology. And thank you, sir, once again.
Thank you, ma'am. Thank you so much. I would also appreciate if we can
have more sessions. I will,
okay,
in due course of time, I will contact you. Thank you so much.
Thank you, ma'am. Thank you so much.
Om Amrideshwari Namaha. May you become more and more famous. Amma bless you. Please come and see our Amma also. Thank you. Yes, I welcome Sri Lakshmi for the Shanti Mandra. Thank you.
Om Lokah Samastah Sukhino Bhavantu. Lokah Samastah Sukhino Bhavantu. Lokah Samastah Sukhino Bhavantu. Om Shanti Shanti Shanti. Om Sri Gurubhyo Namaha. Harihi Om.